Day 20, part 5. Here we go. I'm going to write these out. Hopefully you guys had a chance to try them. Quotient rule. Using the quotient rule, that should be derivative. So using the quotient rule, Hody Hi minus Heidi Ho over Ho Ho, we end up getting f prime of x equals x squared plus 4x minus 4 all over x plus 2 all squared. All right, on to the next one. Again, quotient rule, this is what we get for a derivative. So make sure, hopefully you're getting these same things. And we'll talk some more about how far to simplify, and for right now that's as far as we need to go. All right, next two. Okay, so we go down all these steps using the quotient rule and then simplifying, and we get this. And now hopefully what we notice is this 1 minus cosine theta right here I can rewrite as -1 times cosine theta minus 1. And now when I do that, this factor in the numerator goes in this factor with the denominator, and it's going to be -1. So 1 divided by -1 is going to be -1 all over 1 minus cosine theta. And that's our derivative. Okay, let's go on to the next one. And before we get going too far, notice I have a fraction in the numerator, so let's write that as a common denominator. So common denominator is x, so I get 3x minus 1 over x, and then whenever we divide, I'm going to try write that as x plus 5 over 1, so we're going to multiply by the reciprocal. So now, and we haven't even started yet, we're still just talking about what the original function is. I get 3x minus 1 all over x squared plus 5x, x times x squared, x times 5. Now take the derivative using the quotient rule for differentiation. Okay, and using the quotient rule, this is what we get for our derivative. So use the quotient rule and then simplify the numerator, and we'll just leave it like that. Okay, all right, let's go on to the next one, which I think we have to do a couple ways. We're kind of proving what the quotient rule is. So show using the quotient rule that if f of x equals x squared plus 3x plus 2 all over x squared minus 1, then the derivative is equal to -3 all over x minus 1 all squared. So let's do the quotient rule to prove this. Okay, using the quotient rule and simplifying the numerator, we get down to here. Now I've written the denominator two different ways. I know what I need for an answer. If we come up here, I know I need my derivative to be this. So there's my -3. But I somehow have to cancel this, and there's two ways I could do that. So when I have this denominator x to the fourth minus 2x squared plus 1, I'm going to first do long division, divide by this, and then we'll talk about a shortcut way. I don't know if you guys would see that, but let's do long division here. Okay, so as you can see, when I take that denominator factor by the numerator factor, I get x squared minus 2x plus 1. And I know this is equal to x minus 1 all squared. Hey, that's what's in the answer. So let's go back and look at how I might have been able to do it as a short. So again, when I'm here, I know it's going to work. It's going to get me to that answer, but you don't want to have to go through that. So let's look at another way to do this. So we get -3. Hey, I know this is x plus 1 times x plus 1. I know this x squared minus 1 all squared is x squared minus 1 times x squared minus 1. So I can now write this as x squared minus 1 is x plus 1 times x minus 1. That's this one. And then the other x squared minus 1 will be x plus 1 times x minus 1. And now those x plus 1's cancel out, those x plus 1's cancel out, and I'm left with -3 all over x minus 1 times x minus 1, which is x minus 1 all squared, which is what we're trying to get to. Okay? A lot of work, that's hard, but something we should be able to do. So now, same exact thing as what we did on the product rule, very valuable lesson that we must learn when we're introduced to the quotient rule. So that saying first factor, simplify the function, and then once we get it completely factored and simplified, then differentiate using the quotient rule. Let's see what we get. So the numerator becomes x plus 2 times x plus 1. The denominator x minus 1 times x plus 1. The x plus 1's cancel out, so my original function now can be simplified to x plus 2 all over x minus 1. Now let's use the quotient rule to take the derivative. So ho-de hi minus hi-de ho all over ho-ho. And now let's simplify the numerator. Uh, and I get x minus 1 minus x minus 2 all over x minus 1 all squared. And the x's are going to cancel out. And I get negative 3 all over x minus 1 all squared. Much, much easier. So down below it says, what is the lesson to be learned from the algebraic analysis above? And what we find out that if any rational function can be factored and simplified before applying the quotient rule, we want to do it. Um, it does not make nearly the mess that not doing, not factoring, it will make. Obviously, the previous time, there was a lot more algebra to be done. So let me write that down, and then that'll be the end of this part. There you go. All right, we're going to go on to part 6, and that should be the last part of the day 20 notes. So